Okay, so we proceed to another another problem. Here we are to determine the adequacy of a column subjected to an axial compressive force of 880 kilonewton and a bending moment of 330 kilonewton meter in the x-axis, okay, x direction. Now all relevant properties and data are shown below. Okay, so ako lang point out din itong force din is applied force, compressive force. Okay, 880 kilonewtons. We have our bending moment in the x direction, which is equal to 330 kilonewton meter. And muna siyang kuha ng properties sa itong flange na yun din gamit. Okay, we're using an I-beam sa itong column. Nang iyaha din kuha din diri na siya depth of 367.80 millimeters, thickness sa web which is equal to 15 millimeters. Ang kuan din yan sa nakatong dimension niya, ang width niya rather sa flange. This is true for top flange and lower flange. Okay, that is 372.60 millimeters. We have thickness of flange which is equal to 23.90 millimeters. We have ang area then cross-sectional area na saya is 22,774 square millimeters. And then we have our siyang radius of gyration bitaw atong 1/3 sa tuang 1/3 sa itong flange, itong another sa relevant na beam data RT, which is equal to 102.62 millimeters. Okay, I think ma-remember ninyo sa kaning term, ma-remember ninyo sa inyo ang previous lesson about beams. Okay, that will be used there. We have also ang ang inertia, which is equal to 574,399,000 mm to the 4th power. Medyo mouthful, gamay, lisod na kayo. Okay, so this is our section modulus, which is equal to 3,123,431 cubic millimeters. We have our radius of direct gyration sa x na axis. We have 158.81 millimeters. We have our inertia sa y axis, which is equal to 206,035,000 mm to the 4th, and we have our section modulus sa y direction, which is equal to 1,105,931.29 cubic millimeters, and we have an rx of ry initial rather 95.12 millimeters. Okay, ang kung sa din na saya then another relevant na column properties is that we have a k of 1.0. This is to be assumed na kaniyang value. Our brace length is equal to 6 meters. We have our fy of 248 megapascal. Ang ato ding e then there is 200,000 megapascal. Elastic modulus, we have our CV na term then it is assumed to be 1.0 and cm for both x and y na directions, that is 0.85. Okay, amplification factor na to 0.85. Okay, but anyway, just give me an opportunity to clear things up din kay muragdagan kayo. Ako naman siyang gisulti. I think you can just pause the video if you want to view it more. Okay. Okay, so I'll just place in ang katurang mga relevant na information for now. All the rest katong di pa magamit, ako lang ibalik lang to na siya later on sa video. Okay, so first na step yun nato din para sa organized na approach. I go first with the column analysis. Okay, the column analysis kani siya, this dictates the direction sa imong solution set. Okay, dari man nato mabalaan katong 0.15 bitaw na na benchmark. If siya unsa siya na klaseng kwan, small compression or large compression. Okay, so we go first with column analysis. The first na tong kwan na nasaya then, okay, we go for CC, which is equal to 2 pi squared E over Fy. Okay, that is just kini siya 200,000 megapascals. Sige lang, I'll just din na ako do away na kuan ng mga kuan. Okay, taas ba gini siya na kuan solution. Okay, anyway, I've given it dito sa tong first na video kung saan na mga units ani niya, just to give you a good feel kung saan siya. 126.169. That is for CC. Okay, so KLX RX daw kuno ta. Okay, K is just the same sa kwan, X ug Y direction. 1.0 LX, which is equal to I'm sorry, nakalimot ko, but L is equal to 6 meters. Okay, dapat na ni siya daan diri. 6,000 millimeters divided by Rx, which is equal to radius of gyration 158.81. This will come out as unsa man na siya, 37.781. Okay, this is our slenderness ratio na siya ha. I would just like to prepare na lang po din diri KLX over RX CC. Okay, that should be equal to 0.2994. Just divide this term over kanisa tong compression index and you will have this. Okay, aside from that, napo ko ikon din kanisa y direction na po lang atong ikon assess. That is equal to 1.0. We have 6,158 na no. We have 95.12. And that should be equal to unsa 63.0078. Okay, that's the number. KLY over RYCC, ako na siya ikon, divide by 126. That should be equal to 0.4995. Okay, this is for x-axis and this is for y-axis. Napatay ko na, ngay bantayon na siya dito. Mabantayan nato na siya. This is below, kani siya below raman siya 126. Kanisa siya below ra gyapon just 126. So safe to say that either direction we're just going to consider short column analysis. Okay, the member is not slender in either con. Member is not slender. Butang dinibi. Member is not slender in either direction. Okay, maway manggaling shore X, it's not slender because ato ang kwanda ni slenderness ratio is way below sa tuang CC. Okay, below siya, below ang do. Okay, so ato na siya na clear up din gamay. Let's proceed with content. I would like to go first with x-axis lang sa. Okay, x-axis lang sa ta. Kaya ito magatanawon da niya sa ang kuan weaker axis ani saya. Ato i-check din yung asang kuan. Mas muy kuan man kay when you're talking about axial na kuan compression, it can bend either way sa x or sa y axis, di ba? So in order to determine katong FA unsa nga atong i-refer na axis, we need to solve first both. I-find out na to na ay din ta makabalo din kung sa atong kuan din na next move. Okay, so sa nga na case diri short column analysis din ta. go to SFX. Okay, ang kuha niya din we have 5 over 3 plus 3 over 8 KL RX. Kana lang, general lang sabi. Kasi ako like one X lang sa una. CC minus 1/8 KLX over RXCC. Okay, this is in cube. We already know the value ana saya dayon diri, which is equal to 0.2994 minus 1 over 8 0.2994 cube. Okay, then we can find out din ana saya ang atuang value dari ni SFX, and that should be equal to 1.7756. okay, this is our S of X value. Okay, so much for kwan. We can now go for din bending. Ang katong stress niya. Okay, so this is just basically 1 minus 1/2 KLX over RXCC squared, and this is FY divided by, so kana siya, diba? You just need to plug in everything lang dayon, diba? 1/2 KL over RXCC, that is equal to 0.2994 squared FY, which is equal to 248 megapascals. This will be more siya ma-retain na rin na unit SF1 1.7756. okay, all of this will correspond to sa man siya 133.411 megapascals. Now, so much for sa x-axis. We now proceed to kuan y-axis na sa dayon, ba? So nga na case din dito, same gyapon siya na procedure, just like ganiya. SFY lang atong kuan din consider na axis niya. Okay, so we have 5 over 3 plus 3/8 KL Y RYCC. Okay, minus 1 over 8 multiplied by KLY over RYCC cube. Okay, so ako na siya ikon diri plus 3 over 8, that should be replaced with 0.4995 siya, 0.4995 na po siya cubed. So we have unsa SFY is equal to 1.8384. Kung siya tong SFY, so now that we're done with SFY, we can now go solve for it yung stress na po dayon, di ba? So I have FAY, that should be equal to 1 minus 1/2 of KL Y over RYCC. Okay, that is squared. We have FY then diri divided by SFY. That should correspond to this na dayon. That is 0.4995 squared multiplied by FY, which is equal to 248 MPa. Okay, I just need to substitute the values lang. SFY is equal to 1.8384. Okay, Note, MPA will be the retained na quandary unit ani siya. So FAY na din nato dari. That should be equal to 118.0 711 MPA. Okay, this will be the value sa tong quandary. Sana axial stress sa y na direction. Adjust lang. Okay, so at this point ato naman na investigate both na kung na axis and na din tayo kabuk kung sa kanang corresponding na values of FA, diba? Allowable na to na compression. Now ang ato na sang concern din nga magpili ta asa na lang duha mo prevail, or rather mo govern sa to ang design. We have FAY, ang limit lang ani siya kay 118 megapascals, whereas ang atong FAX 133.411. Okay, we cannot go beyond sa kanina number. Nga naman, if we ever reach even 120 megapascals, that is greater than unsa makaya sa y-axis. It will start bending sa kanina direction. Mubakol na siya sa y direction if mo exceed tani. Okay? Pero di siya mubakol din eh. Muna siyang ang concept na to. So therefore, ang ato ding pilion din dari na number k kani. We choose this. This will therefore be our FA. Okay, allowable na to na compressive stress. Okay, so much for sa tong kandani, allowable na axial stress. We now go to kani siyang FA na din nato na itong gamay, di ba? Kani siya. So that is just a basic equation of P over A, di ba? That is stress, force over area. So our force here is equal to 880 kilonewtons divided by ang area nato diri, which is equal to 22,774. I'll just divide this by 1,000 squared, and that should be equal to 1 squared. Ano siya, nagyapon na siya ginagmay na tweak gyapon. So we will come up with din sa 38.641 megapascals. That is our FA. Okay, now before na ko na siya isuot din ato sa i-investigate ng ani niya kani siyang rather. Okay, solving for FA divided by FA ba? We have FA that should be equal to sa 38.641 megapascals divided by 118.0 711 MPA. This cancels out. Ang mabilin din dali sa tuwa din kay unsa. That should be equal to 0.32726 ba? Muna siya itong makuha na number. If kani siya din this is actually greater sa itong benchmark, which is 0.15. Therefore, we can conclude then din that we need to consider large compression effect. Okay, large compression effect. Ato na siya i-consider na din. Dahil sinid na din na mo agit atong taas-taas ng mga interaction formulas. Okay? Okay. So here comes the next portion sa atong solution dire. We're done with the analyzing this as a column. Now we're analyzing this as a beam. Okay? Beam analysis na punta. Talking about beam analysis din we need to verify first. Atong first step ani atong previous na to lesson kay we need to verify ang kwan niya, ang length sa to ang brace length na to, di ba? We need to compare it with LC and kwan duha ka book values ni LC lugar silbi. Now we have LC1 lang zero akong designation ani siya ha. That is 200 BF divided by square root of Fy. That should be equal to 200 times BF na to, which is equal to 372.60 divided by square root of Fy, which is equal to 248. Okay. By the way, ako say run through the daan. Force is equal to 880 kilonewtons. Moment is 330 kilonewton meter. BF is 372.60 millimeters. D is equal to 367.80 millimeters. Area of flange, this is our AF area of flange na siya. That is 23.9. That is the thickness of our flange multiplied by ang iyang width dyan, which is equal to BF 372.6. Ako lang siyang square daan pero understood na siya na multiplied na siya niya. Okay. TF is equal to 23.90 millimeters. Thickness of our web is equal to 15.00 millimeters. Our E is equal to 200,000 megapascals. Our Fy is 248 megapascals. Our braced length ani saya kay 6,000 millimeters or 6 meters. Okay. And our RT dayon the radius of gyration with respect to tong kuan upper 1/3 sa kuan RT, which is equal to 102.62 millimeters. CB then is assumed to be 1.0. Okay. Going back to this, ako lang to siyang gikuan kay sa kalif dili siya maklaro, madunggan niyo yung voice, you can still follow through. So solving for this then diri, I will have LC which is equal to 4732.025. Okay. That is for LC1. Now LC2, that's a different story. That is 137,123 divided by dFy over AF. Okay. Our quantity this is 137,123 divided by 367.80 multiplied by 248 divided by 23.9 times 372.60. Okay. Again, this is the area sa tuang flange. Okay. Width times thickness. Okay. Kani siya depth times turing Fy din diri 248 nya kani din siya value. That should be equal to in millimeters we have 13375.12695 millimeters. Okay, so we have something like this dayon. Now ang content din ang condition na sa daan ni saya dayon, whenever we're calculating for critical ana niya na kuan braced length, piliyon na to ang lower limit. Asa ni sila mas ubos na value mo tong pilion. So LC unanimously would be equal to 4732.025. Okay, millimeters. This is what we will choose. Atong pilion nga number. Okay, ang LC. Then ato pa i-consider din dan si braced length, which is equal to 6,000 millimeters. Muna sa niya itong bantayon diri. How will they compare? Ato din makita din diri na LB is larger than LC. So muna siya nga itong kwandayon. This will dictate the next part sa itong solution. Okay? Okay. So, ato naman determine si kuan din nga naman na ang naabot nato, napala nato. Okay, so we now proceed with slenderness na din na analysis ani saya ha. Now we have L over RT, and that should be equal to unsa? Pila man ni siya dapat? LB man nato. LB is equal to 6,000 millimeters divided by RT, which is equal to 102.62 millimeters, diba? This cancels out, and that will be just unsa 58.4681. Nating na nakon currents din. Now na din so siya i-compare din nato na lower limit ug upper limit, diba? Remember mo ato niya, our lower limit ani saya ha, that should be equal to unsa sa sum to be this na siya square root din eh 703,270 CB divided by FY 703,270 CB, which is equal to 1.0. I believe na ako na siya gihatag na siya dito. FY, which is equal to 248. Na din tayo na ni dara. And that should be equal to unsa man ni siya. CB is equal to 53.252. Okay? Note, mas dako pa siya. Ang lower limit is lower than kani. So maybe this is something in between din. Now ang upper limit na po din nato diri. This is the square root ani siya ha. 3516,330 CB divided by 5. If ako ni siyang i-con diri, substitute din nato. That would just be 3516,330 1.0 248, and that should be equal to 119.0745. Okay, so nating una ni din akon. We come to the conclusion din diri atong ma-observe na lower limit is kani siya L over RT is upper limit. Okay, kani atong mabantayan din. So this is in somewhere in between aning duha. Now we have a con din. Muna siya mo dictate na din sa another part sa atong solution. Bakit naman siya separate treatment ng kana na con so pag-solve. Okay, allow me to make room sa kadjut lang. Okay, now ato na siya na con din na determine na to yung siyang criteria sa pagka-slender niya. We now go for con unsay bending stress ani niya, ba? Naman tay mga tulo ka book choices ani saya diri. One choice, I'll just call this as FB1. Muna siyang pinaka-bulky tan-awon nga kuan formula sa mukan gay ko. Ana, masyada siguro unahon na tong pinakasamok ng mga formulas, okay? Because well, ang samok siya. Mas conscious na kanang it will take more energy, so by the time if kana bitaw masyada man ang matubang nimo ni napakay kusog bitaw para full powers ka kaysa matubang ka ni saya luyan na kana siya mo ikapoy kayo multiplied by FY pag yun. Okay, so we have 2/3 248. This is 58.4681. That is in squared divided by 10.55 times 10 to the power of 6 CB 1.0. That is in FY 248. FB1 therefore would be equal to 145.404 MPa. Okay, that is our FB1. Now, second answer na to na FB diri kay FB2. This is 827.40 times CB divided by LD over AF. That is 827.40. CB is equal to 1.0. LD na to. L is equal to 6,000 multiplied by D, which is equal to 367.80 divided by AF. AF is equal to 23.9 times 372.6. That should equate to pila gani siya be 333.882 megapascals, and that should equal to sa FB2 is equal to 0.882 megapascals. Okay, so we have another condensation na kanang contestant. I hope makakuha nyo siya. Just try to rewatch the video na if gusto mo mag-go slow na kay murag gabi na kay kataas. Okay, so napagintay tayo kundi last na contestant na po dayon be FB3. That should be equal to sa 0.60 FY ba? That should be equal to 0.60 times Fy of 248 megapascals, and that should be equal to sa 148.8 megapascals, diba? FB3 148.8 megapascals. So nag-solve ta nagtulo ka book values. Now the idea magud ani sa iya sa I don't know if mo siyang exact nang ma-remember, but you choose the higher value of these, but it must not go beyond sa 0.6 Fy. Okay, you choose either ang higher value ani ni FB ning duha, pero dapat siya mag-go beyond ani. So tabo man ani siya na FB1 at FB2, so atong pilyon dapat si FB2 ba, but then dili siya dapat mag-go beyond sa kuan kang FB3. So the winner of our contestant here is FB3. We choose FB3. Okay, if gusto mo makabalog yun sana ako pag-rate sa criteria sa contestants ani siya, just view katong previous na videos about beams. Okay, so now we choose, therefore choose FB. Kuan ba ni siya, keep in mind na this is still FBX. Okay, gamay makikalayo. FBX is equal to FB3, which is equal to 148.8 megapascals. Okay, therefore choose this value. This guy wins the contest. Wait na, pwede ko gusto isingit ani siya, habi. Allow me to erase lang sa diri gamay. Wala naman si FB1 ug si FB2. We have this naman. So akong gusto na sa dihmon ani siya na TFBX. Napatoy moment di ay, di ba? Kani siya FBX na katong gamay. We have just MX over SX ba? Moment over section modulus. Moment X na to diri, that is equal to 330 kilonewton meter. Okay, divided by SX, that is equal to sa wala tayo SX. SX is equal to akong nalimtan og sulat, sorry. Sx is equal to 3123431 mm cube. Okay, I think ako man ang nakuha dito ganyan, so tanaw na lang dito 431, that is divide na ko siya by 1000 cube. I'll have this, but either way ang arrival din ako na sa iya, that will just be equal to 105.653 MPa. Okay, so FBX is equal to kani nya kana din siya, FB is equal kana. Last na din akong gusto mo na ni saya, I'll just sulat na ako sa dan kay para ease na lang din bitaw. Yeah. I'll just divide this by this para makuha na ko ni siyang kanina ratio. So I will have 105.653 megapascals divided by 148.8 megapascals. Both of these cancel out ng ngayang kuha na common unit, and I will just have 0.71. Okay, natingan niya klaseng ratio dayon.